Hello and welcome back to a new video in my Unreal Engine 5 Let's Recreate the Time reversibility from Life is Strange. Well, as said, in this video series we're going to recreate the ability from Maximum Caulfield or from the game Life is Strange. So Maximum Caulfield, basically she can rewind time, and we already implemented a bunch of stuff in the last video. So here's our nice little test course. We have implemented like this nice little train that goes around. It's a nice deterministic simulation. The character that can walk around, press control and revert this nice deterministic simulation, and the train just goes backwards. We also implemented a few checks and parameters to basically limit the power so that we cannot use this infinity and that we cannot overuse this. So basically we cannot start the level and rewind time to times that have never happened. So just a bit of checkings and a nice little functionality also for gameplay related stuff like enabling and disabling the power programmatically and stuff like that. So this worked all nice, and this worked easy for this train. Why does this work for this train? Because this train is deterministic. We can take every point in time. I can, if I have the equation in my mind and know the correct time, tell you where the train is going to be in 10 seconds. I don't know it because I'm not a computer, but if I would have a function, the function could always tell you, hey, in 10 seconds the train would be there at a certain point. The function could also say, hey, 10 seconds before the train was there. So this basically means deterministic, because we can basically, it's just a function. We just move at a certain speed. And because we just move at a certain speed, it's very, very easy to predict where the train is and also to reverse it. Because if we are forwarding the time, we take the delta time and multiply this in our equation. When we take the forward time and multiply it by -1, the train moves backwards. So all nice, deterministic, easy. And if the world would be 100% deterministic, or our full game would be 100% deterministic, well, the time power would be easy to use. But actually you would not even need to implement this. You could take out old Adobe Flash, old Premiere Pro, and then you would just record a movie with real actors. Looks like reality. You can take real actors, you can do this, and then you basically just take good old Adobe Flash, which is deprecated, lol, but you would take good old Adobe Flash and you would implement that the movie is going to be played backwards. This would be nice deterministic, but that's not how games work. Games are interactive. Things fall around, people can push stuff, collect stuff, interact with stuff, like the button. People can interact, and that's why we have a game. Interacted, simulated, all on the PC. And this makes the computer game non-deterministic. I mean, you might have such nice things if you don't fall off. Nice things like this train in the game, just some gimmicks that move around. These are easy. These are deterministic, you can easily implement them. This is also why we started with them. You're gonna have deterministic in your game, like this train here. But the majority of stuff that you need to implement for the time power is gonna be non-deterministic, and that's what makes Life is Strange fun. Because you can revert like things you destroy, conversations you did with people, and then use the information to go into the conversation again and get a different outcome of the conversation. It's amazing. You can basically use this time revert ability to hack you through the game if you would take this like that. But of course the game is designed to need this ability. And then Life is Strange also gives you decisions and different endings of the story to make it superb. So yeah, we have some other deterministic shit in that, like that button that I can press. I mean, this didn't pop out, I just pressed the other one. I didn't press, oh yeah, I fall off, okay, yeah. That's a fair point. So, deterministic, easy. Non-deterministic, not popping out, hard. Why is that? Because it's not deterministic. We cannot predict the old state from the current state. We need to have a history available. A point in time. We need to have a time point somewhere stored in memory that we can later on take a look at and say, ah, right, at this time point we pushed the button. So if we go backwards over this time point, pop the button out. This is what we need to do to get this ready. And, well, that's why we need to implement a time point, and that's what we're going to do in this video. We're going to implement a time point. So to recap, what is a time point? What does it need to do? A time point is a point in time. Okay, so the time point needs a timestamp. World time in the Unreal Engine is just a simple float that tells us how many seconds the level was running. Okay, so time checked, floating point value time. What else does this time point need? Well, the time point. What time point? Actually, a button time point is different than the time point of a cube. So a cube that is physically simulated, and the player can, for example, throw around the scene or shoot, like in the default Unreal Engine example, where you can shoot these balls and the cubes spin around and go mad if you hit them correctly. This all needs to be kind of like saved. So a cube does have a position and a velocity associated to it, which is used by the physics system to basically interact with it. So position, velocity, all nice and good. These two values needs to be in a time point. If you simulate a cube. If you simulate a button, well, position, no, the button is statically. It's just pressed or unpressed. Button does not need a position. Velocity, no, button doesn't need a velocity. Okay, screw it. We can't create a time point because everything does need a different time point. Would be the first idea. So we would hardcode it for each entity that we have, for each type, for each actor. Implement this differently for each actor, but no, that's not good. We want to reuse software and we want to have a uniform container and a uniform way to store these. So the correct way to go is to make a base class. A base class that just have time associated with it. So just base class, maybe we're going to call this time point base. Time point base is just going to get one floating point value that has the current time when the time point occurred. And then we're going to take hierarchical stuff and build a hierarchy on top of that. So we can maybe create one with a blueprint, in a blueprint with a Boolean value for the buttons. We can in the blueprint create one with a transform and a velocity for spinning cubes. So I want to basically have a base class and then I want to basically record data. Alright, simple and nice. Okay, done. You will think done. We can start implementing. No, there's one important thing missing. Interpolation. Why do we need interpolation? Well, on a button it doesn't really matter. On a button we just record the binary state true, false, and as soon as it is pressed it is true, and as soon as it unpressed it is false. And what we would have in code, if we are rewinding time, we would just step through all the recorded time points backwards, and as soon as we pass a time point and it changes from true to false, we just represent the state by popping out or in the button. Very simple, easy, don't need interpolation. But what is about a spinning cube that flies around the scene? Initially we would think, okay, each frame is like 60 milliseconds long. So every 60 milliseconds we record a time point and we could just step them back every 60 milliseconds. We don't need to interpolate there. Correct, we don't need interpolation if every frame is 60 milliseconds, because we just take the last one and very nice. But what happens if we have a lag? So somebody plugs a USB stick in the computer, Windows got confused and the graphic card halted for a second, and however this shall happen, but let's just assume graphic card had an issue or something happened on the system and we had a lag of 1 second. So during normal playback of our game, the cube is moving, we have a lag. One frame takes 1 second, physics system needs to respond to that 1 second duration. So 1 second passed without physics simulation. Okay, physics simulation needs to simulate the moving object to move for 1 second of time, and visually you would see the cube jump. Because 1 second no simulation, 1 FPS, not good, jumps through the map. Okay, so position change, velocity change, a big change. You see it in the screen, it jumps. Can happen, lags are not fine, not nice, but it can happen on a user system. You can't predict that. So this lag happened now. Now we are trying to reverse the time, so we're going back through our time points. What does now happen if we have this big lag in there? Well, this would mean, because now, let's just assume during reversal we don't have any lags. This would now mean that we have one time point for 1 second. And this would mean that even though we are not having a lag, you would still get the same laggy experience when playing back. Which we don't want. We want to compensate for that. And for that we're going to need interpolation, because then we can basically take 2 time points and during the lag we can interpolate between them. Okay, this might not be the real movement of that object, but it is probably quite close. So we have at least some information to interpolate between these two values. So we can revert the time and nicely interpolate. So our time point also needs the functionality to interpolate, independent of what blueprint construct might be on top of that. In C++, easy pure virtual function, or not even pure, even like just a plain virtual function. But this is the challenge of today, how to implement this in blueprints. to be overridable by blueprint implementations of our nice little handy C++ base class. So let's get started and see how we can do this. Alright, so first of all, I want to create a new C++ class. I'm going to zoom in the future because now this one is not like properly scaled. Alright, so let's go to all classes here because we don't need a common class, and let's select object. So we're not going to use an actor, none of these advanced stuffs, just a plain good old object. Never used them actually before, but object is basically the most primitive type you can basically inherit from. I'm going to call this Timepoint base. So Timepoint base is our basic time point. Create this class. There we have it. Nice. Alright, so what does this class look like? It's not quite different than what we had before. Just that we are not like going from an actor, we're just gonna go from a new object. Now, how are we now gonna bring this in? If I would now take a look at the engine, now I can actually zoom in. You would see that we have this timepoint base here, but if I would right click this, create blueprint class based on timepoint base, we cannot select this. Why is that? Well, it's because the U class does not allow this. We cannot create a blueprint on top of that because U class does not allow that. Why is that? Well, it is because the U object is not a U class. Okay, I lied to you. It is actually a class. It's a U class, but it does have some odd parameters in here. Abstract because it's an abstract class and no export, and it has something in here that we don't like. So these default properties that are based from the U class macro, we really don't want them. They are nothing we can deal with. So if we would compare them with the actor, for example, if I would pick the actor, you can see basically this actor is specifying a hell of a lot of useful stuff that make this usable. For example, it specifies blueprint type, and blueprint type means, hey, this is a type that can be used in blueprints, and from now on you can use this in blueprints. And it also specifies this blueprint able, and this blueprint able means, hey, you can create classes on top of that, and this allows us to right click and say create blueprint class on top of Bloom. And this is something that we want. We want to have both of them. We want to have this exposed as a type for blueprints, and we also want to be able to use it from blueprints. If I would add them, quickly hot compile that in, we would see that if I now right click this, we can create a blueprint class based on timepoint base. So this solves that issue. So let's continue on solving the other issues. So first of all, okay, do we have any issues? No, we just need to implement it. All right, okay. So what do we need in this one? We need some variables. So first of all, a U property, so like that. Float time. So as I told you, a time point needs a time. So this is the time of the time point. And we also want to make this accessible. Blueprint, read, write. Okay, so now we have a time that can be written and written by the blueprint. Okay. First thing done. Now the interesting part comes. Now we want to implement our virtual method. And this works a hell of a lot different in blueprints than in plain C++. Before we're going to get into the details, let's just create a very basic signature. Alright, so interpolating between two time points. How does interpolating work? One time point, another time point, final time point. So input, 2 time points, output, 1 time point. And now, how do we implement this in C++? Well, in this case, because it's Unreal, U objects always needs to be pointers. U time point base, pointer, interpolate, and we want to interpolate between left and right, or this and other. We're going to go to this and other approach to basically interpolate between ourselves and another object. So this and a const U time point base pointer other. So we want to interpolate between this and other and return a new one. We need another parameter there actually, because interpolation is of course not a binary operation. This is why we have interpolation at all. We need a interpolation value, and I'm just going to call this float distance. So the distance between these two that we want to interpolate. This is a very basic signature. All right, so normally you would do something like that because interpolation should not modify the current time point. But this is 100% fine, and I would love to use that, but this is gonna screw up in blueprints. Because blueprints are, as it seems, or it is a bug, I'm not quite sure of that, blueprints are not aware of const references. So by making this const, it does not allow us to modify any member of our uTimePoint base or any class on top of that. That would be fine because we don't want to modify members. But the thing is, in our implementation later, we're going to create a new object of type whatever time point, and then we want to modify something on top of that. And by having this const, it does not allow us to modify our own types, even if they are not in the current instance. The const is kind of like not working correctly in blueprints. It kind of works, but it doesn't work. Let's just give you one important advice. Do get rid of any const there. Do never use const with blueprints. Even though it hurts me. It really hurts me because in C++, everybody would beat me and say, hey, now I could accidentally change their own state if I interpolate. Yes, but in Unreal Engine, if you wanna interpolate, don't use const. If you don't need to do anything, if you don't need to do something with any of these members, is it the member here or is it the member in a topper class, you will not have const here. If you don't need to modify them, it's good to have const there, but it's gonna remove you a lot of issues if you remove it. So we gotta get rid of that. All right, so this is gonna be a U function. It's gonna be blueprint callable. Blueprint callable, okay, so we can call it from blueprints. And yeah, now we are actually good. But we are actually not good because we want to be able to override this with blueprints. And to be able to override this with blueprints, we need to assign this to a blueprint native event. I have no idea why this is called event, because events are actually a different thing in Unreal Engine. But this is not an event like an event that we're going to do in the future for populating state changes in our system. This is not an event, but it's a blueprint native event. It would be more like blueprint overridable, would something that be more sensible, but no, they didn't call it like that. It is called native event, even though it makes no sense. And by having this as a native event, it is going to automatically implement this function for us. So as soon as you have a native event in here, you're not going to touch interpolate. Now you would imagine and ask me, hey, how do I add a default implementation or implementation to that? Well, duplicate the function and add a underscore implementation. Then you're going to go and make this private, maybe even virtual if you like. And for the sake of God, bring back your const. At least that people are... Yeah, at least the people are not killing you on the C++ side. This at least will keep you safe if people are implementing and overriding this on C++. Blueprints is a different story, but here we can have our holy const thank you live. Alright, let me add a bit of documentation to show you how our interpolate is gonna work here very quickly. Alright, so this one don't implement, it's going to be automatically implemented. This one implement. So how does interpolate work? So interpolate works by having a t minus or minus t. Actually t minus is better. I don't know why I named this whatever. So t minus and a t plus. T minus and t plus. I'm an idiot because I formatted this not as I like it. So yeah, there you go. So we're going to have a t minus and a t plus. So the t minus is always going to be the dis reference, and the t plus is going to be the other that is going to be supplied to the function. And rv is our return value. This is basically the time point that is currently on and basically indicated by the distance. So basically our new time point is t minus plus distance times the abstract between t plus minus t minus. So the distance between these two time points, absolute value, multiplied by the distance, is basically showing where we are. So this is just some very basic information here how the function works. So if the time goes forward, it basically means that t minus would be 0, t plus would be 1, and our desired time would be 0.5. Then if we go forward, would mean that t minus is this, t plus is other, and the d would be 0.5. If we go backward, it's just the other way around. This is just handled on how I am going to call this interpolate function and how you should call it as well if you're not using this for reversing the time. So this is just a contract how this function works. Just some logical imaginary construct so that nobody screws up here. Because it's easy to screw up in functions like that. But it's also easy to see why you screwed up if it interpolates the wrong way around. Alright, so now let's add a default implementation here. So our interpolate implementation. Implementation, I hope I spelled this correctly, but I should. Okay, so here now we need to implement. What is our default implementation? Well, as I already told you, our default or did I told you? I don't know. But our default implementation is going to be a binary choice. A binary choice means that basically, let's take a look at our documentation and take a look at this. Currently, we are at t minus and we want to go to t plus, which means that t is somewhere between this and other, which means that we have not reached other yet, so our binary decision should yield this. And now you would be tempted to return this here. But as you can see, C++ is not going to allow us that. And I'm going to show you a bit of magic, even though we're going to delete it in any second. If I would implement the interpolate function here, I would be allowed to return this. Why am I allowed to return this here? Because it's not const. And this is why I hate that we are not allowed to put const in here with blueprints. Because const is gonna solve us for issues like that we return this. Because return this is not the sensible way what you do if you're interpolating. If you're interpolating, where you take two positions and create a new one. And this is why this is not allowing us that, while that one allows us that with the function signatures. And this is why I hate that blueprint screw this up. I mean, we are not allowed to do this here because it's what? It should be like that, but yeah, still not working. So it is an issue. How are we going to do this here? Well, we want to copy an object. How can we copy an object in Unreal Engine? We want to basically not call copy, because copy is kind of like implying that we already have the new destination. We don't have them, so we want to basically duplicate something. Duplicate object is the function that we want to call. It is going to take a source object, which is our this pointer, and then you would think you're done. But no. If we take a look at this, we actually need more for duplicate object. For duplicate object, we need this U object pointer outer. And this outer is the owner of the object, because U objects are owned. They are owned by something. So what would you use there? Now we would be tempted to say, okay, the owner of this U object is the class that is calling it. However, we cannot really get them in C++. But as you can see, we can put this to null pointer or invalid object, this outer, and it's going to get the transient package as the owner. The transient package is a non-serializing package that basically is destroyed when I think the game or level is, however, I think level. I think transient package is either by game or per level or world. Just a special object, a so-called U package. Okay, it's a G, whatever. We don't care. We just care that we can put null pointer in here, right? And we should be good. In the future, we might want to resolve this to have a proper owning reference. We could do something like, say, this is going to own it, which is not going to work because this is const and we cannot modify this. So we're going to add this to null pointer. So it's going to be owned by the package. But the thing is, we're going to delete the objects anyways, programmatically. So we don't really care who owns them, because we don't need to get normal deletion. There's like a delete object that is going to delete an object. Oh no, it's delete. What is that? That is a WinRP function. That's not the right delete object, but we can delete them on demand somehow. Yeah. So we want to just duplicate ourselves, and this is owned by nobody else. As you can see, if I would copy this over, it would work. Here as well. So you really just see the issue when you try to return this here. And this is why I like the approach here. So if you're doing it by default, like default, it's not going to make any difference. But if you're doing it wrong, it makes a difference. Because this one guards you from doing it wrong, this one does not. This is why we have this as our virtual here. But our implementation is by default trusty, rusty, blueprintable. Okay, so this should conclude everything that we need to do in C++ actually today. So let's try to hot reload this in and see if we screwed up somewhere. But we shouldn't. Okay, yeah, worked. Nice. So now live coding succeeded, we got data in. Now we're gonna do what we need to do. We create a blueprint class based on that. I don't care where, we're just gonna try this out. Let's just create it here. Okay, so what do we have now? Now we have an empty myTimePoint base class. What do we want to do here? Well, we want to store a floating point value. So let's add a new variable. Let's call this val and make this float. Come on, I cannot really... whatever. Let's make this float here, public visible, nice then. Okay, so how do we now implement over our interpolate function? Well, as you can see up here in functions, I can see one overridable. And if I would click on that button, you can see override function, and I want to override interpolate. Click on that, boom, here we have it. Interpolate, return, parent. We don't care what the parent does, because we create a new object. We don't care what the parent does. The parent is just a fallback implementation. So what do we want to do? First of all, we have this other and we have this distance. The first thing that we need to do is we need to cast this distance because it currently is a timepoint base pointer. So we need to cast this to a myTimePoint base just to make sure that it is really from the right object, which should, this is actually guaranteed later on, just the way we call it, is guaranteed to always work. This will never fail because at least in normal operation, you don't need to get cast failed here. If you use it as it desired, this is never gonna fail. Right, okay. So basically what we want to do now is we want to take the current timepoint base, get the value. So get value from the other one. Then I want to get value from the current one. Here, get value from our current one, and then I want to do a simple lerp, a so-called linear interpolation. I'm going to take A, which is this, and I'm going to take B, which is the other. The other way around, actually. Lol. To set it right, did it wrong. So lerp this from A to B. So this, if we would compare this to C++, this to other. So lerp from this to other. And we want to lerp with an alpha value of our distance. I don't know why this is actually using alpha as an input. This is looking like it's from a shader or whatever. But yeah, if Epic wants to call it like that, I guess I can just do it and call it alpha. Even I find it really disturbing that it is called alpha. But yeah, it doesn't count what I think. So now we have casted it, and now we have the new value for val. Now we need to set this, and now you would be tempted to set val and then return self. Right? This is something that you would love to do now. Am I correct? Yes, you would love to do this, but this is wrong. And this is why I hate that we can't pass in const from C++. We can, but setVal will fail anyways, no matter if we do it on ourselves or on another reference. Making the function const will not allow setting val on any object, but I just want to prevent it to be set on this object. So what do we need to do to do this correctly? Well, we need to create a new object. So new object from class. So this basically allows us to create a new instance of any object desirable. What object do we desire to create? Our myTimePoint base. So let's give me a new myTimePoint base. Maybe let's rearrange them to create this up here. So yeah, give me a new timepoint base. As you can see, if we do this with blueprints, the outer is set to self. So the owner is the current instance. This is not 100% clean. I would rather have this as null here, but I am not allowed to do this as null, actually. But it's not an issue because this time point that is currently being called does at least exist until the next frame. This is going to be guaranteed the way we're going to do this, so it doesn't really matter who the owner is and early destruction. And we might even need to care about it all if reference counting works as desired, but yeah. Actually don't know if your objects are reference counted. I'm the do it guy, not the know it guy. Okay, I could be the know it guy, but Unreal Engine is very big and learning by doing is the right way here. That is why we have this nice little series. To learn it while we do something. Alright. So now we have this new time point base. And now on this new time point base we can set the value. Right, so... And this would fail. If this would be const, this would still fail here. Bad, but it's like that. And now instead of returning the reference to self, we're going to return the reference to that. And I mean, I think that this is why they are transparent, so that you can do stuff like that, but I find it really ugly. But you cannot get away without making this ugly, actually. But at least I personally think this is cleaner. So now what we basically do, we're gonna take the current value with the other value, take the distance in account, and we're gonna return it and set it as a time point value of a newly crafted time point, and we're gonna return that one. Does it compile? Yes, it does compile. And how can we test that? Well, just quick and dirty in our game mode. Not in that one, actually. Actually in the blueprinted one. Here we can basically, after enabling the ability, I'm just gonna call a new object here, and I'm gonna create a my time point base. So basically a time point from the newly created class. Let's set the val here so that we can interpolate between stuff. So val is gonna be 1 or something. And then what we want to do here is, let's just duplicate this like that, create another one here, and set val to 2, and now we want to take the first one and we want to interpolate from the first one to the second one. So first to second, interpolate please. And the distance to interpolate is going to be 0.5, and then we're going to take the return value, or actually we're going to print a text. So to print a debug text here, this is all good. Maybe let's increase the duration because we're going to be obscure to maybe 5,000. Something like that. Can I make this actually bigger? No. I don't care. So let's do a format text here to get a formatted text in. And I just want to print the value of x here, and x is going to be the... Oh, can I print this whole... No, this is not going to work. This works. Okay, this is going to print some obvious shit. This is going to print a default string to string method from the U object, which is going to probably some UID or stuff. Yeah, my time point base C. This is just the name of the object, okay. But that's not what we want. We basically want to print the get value. Just the hell. Okay, yeah, interpolate needs to be casted as well. Cast to my time point base because it's still the interface function or the base class function, so it needs to be casted to that. And then we can get the val from that, and then with that val we can plug this into... Okay, now X is no longer allowing us to do this like that. Come on, so this should now work. Okay, so now we can just pass in the value that we have, and if I would compile and begin play, we should get 1.5, which as soon as the fucking shift F1 for mouse cursors away, could see. Okay, in 1.1 interpolated. Let's test a few more values out. Let's put this to 0.25, for example. Compile this. Go in. So yeah, 1.25. As you can see, this also works 1.25, so this is all good. Okay, so that concludes everything that we have done today. We can delete this, no longer delete this. So thank you for watching. We're going to see us in the next video where we're going to implement the manager that is going to be responsible for adding and removing and also interpolating time points. So stay tuned, see you in the next video, and to make sure to like and subscribe, and have a nice day.